There we go. Okay, y equals cos x. If I'm trying to find its reciprocal, as I was saying, what does the y value here equal to in here? 0. So what is 1 over 0? We said 1 over 0 is always going to become undefined. So the trick for your reciprocal graphs, which is sec, cosec, and cot, is to look for where their intercepts occur, and they will become asymptotes. So asymptote there and asymptote at that location there. Is that clear? Does that make sense? Then you've got to think about what is 1 over a small number. 1 over a very small number. What happens? A very big number. Right? If you want to put it in your calculator, put 1 over 0.003. Well, that will pretty much give you 3,000. Something like that. Big. So when it's small, it's going to go up very high. It's going to start up very high. What happens when you do 1 over a bigger number, just a little bit bigger? Well, it'll be a little bit smaller. What happens when you do a little bit bigger? Will be a little bit smaller. What's 1 over 1? The highest number I've got, 1. So the lowest number you're going to get is at 1. Does that make sense? Let's try it again. On the left side, what's 1 over a very small positive number? Again, it'll be a very large positive number, so it'll start somewhere up here. What happens as I get a little bit higher? Well, this guy will come a little bit lower. What happens as I get a little bit higher? This guy will come a little bit lower. And what's the absolute highest number I've got here? 1. What's 1 over 1? Again, 1. So it'll pretty much start off at 1 and it'll shoot up to this asymptote. Did we get that? Okay, and then what about down here? What's 1 over a very small number? Very big number, but is it negative or positive now? Negative, because we're in the negative region. So it'll start down here. And then what's going to happen? It's going to come up, come up, come up. Smallest number is going to be -1, and then go down.
It's like an upside down parabola?
It is an upside down parabola. So the way I would have explained it before would have been, if it's happy, it's sad. Sad, it's happy. That's just the idea of reciprocal functions. And that's the answer to y equals cos x. And don't forget, it stops at 2 pi. Maybe I should have been a bit more clearer with this component here. It should have stopped at 2 pi, and then it would continue. And I'll show you the continuations in a second. Yes?
So in order to draw a set graph, you need to draw the cos.
Yeah. Unless you want to memorize each one, which is just more work on top of everything you're going to have for year 12 and year 11 again. Not a smart strategy. It's better just to go, fair enough, kind of makes sense. All right, let's do it. Let's do it a little bit neater one more time. Exactly the same. Y equals cos x is this. I just want to show you the continuation as well. So cos x looks something like this. 1. Okay, that is, let's say 2 pi, and let's say that is going to become 4 pi. And then I'm going to do it to the left as well. Again, that will become 2 pi, and then the last one is, sorry, -4 pi and -2 pi. Do we agree with this? Perfect. That's what I like to see. And we know that it goes up to 1, goes down to -1. Remember, they go on forever. If I wanted to now draw 1 over cos x, which is the same as sec x, what I do is I first look at my asymptotes. Where do my asymptotes occur? They'll occur whenever I'm about to have 1 over 0, something undefined. Where does zeros occur? Zeros occur here, here, here. I think we get the idea. So I'm going to go and draw asymptotes now. So asymptote, asymptote, asymptote. And so on. Okay. And one more. Good? Yes? Perfect. Then, if I said to just draw it from 0 to 2 pi, from 0 to 2 pi, if I said, which is usually the case from 0 to pi, if I said to draw from 0 to 2 pi, this would be your answer. Right? We said we're going to start up here and we're going to approach this asymptote. Then for down here, we said it looks something like this. Then for up here, we said it'll look something like this. And then stops. Do we agree with that? But now you get to see what they actually look like if they were continued. So if they're continued, like if I now had to put this piece to here, what kind of graph would it look like? Yeah, right? And you're just going to continue. And that's why you need to know like how one cos looks like, and then the rest you just continue. So here, continue it. There it is. There's your asymptote, which is the same asymptote as this. Then you're going to get your upside down thing here. There it is. And then up here, you would have the next half. To the left, if I continued it, you're going to get the next your next lot of parabola. There it is. Then down here. And then continue. And continue. So they're just sideways, they're just upside down and up parabolas, aren't they? Normal parabolas and upside down parabolas. That's it. Just that very important that they're not anywhere. They're specifically at the lowest points are at 1 and -1. Cool? But you got to memorize 1. 1 cos, then I'm sure you should be able to do the reciprocals. Let's do 1 sine. So scroll down. Wait, everyone's copied that? Everyone's okay with that? It should be recorded, so you could go back. Cos y equals sine x now. All right, again, let's have a just look at 1. So 1 sine x looks like that. There's 1. There's -1. That's 1 sine x. We need to now draw y equals 1 over sine, which is the same as cosec x. Again, what's our starting point for cosec? Well, what's 1 over 0? It's 1 over 0, 1 over 0. The y values here are all zeros. So all of these are going to be asymptotes. So asymptote, undefined, undefined, undefined. And then, come on, I think we know it, right? What's it going to look like from 0 to pi? From 0 to pi, what's it going to look like? An actual happy parabola. And then what's it going to look like from pi to 2 pi? Sad parabola. Finished. Very simple. So this one. But again, look at it. What's 1 over a small number? Big number. 1 over a little bit bigger, a little bit smaller. A little bit bigger, a little bit smaller. 1 over 1, 1. 1 over a smaller number, a little bit bigger. 1 over even smaller, a little bit bigger. 1 over very, very, very small, very, very, very big. But you don't need to do that anymore. You just need to memorize it by now. Done. Oh, come on. The tip's gone. Okay. That's one cosec. It's 1 cosec. So now let's do multiple cosecs. Okay, here we go. That's if I continued sine to the left-hand side as well, it would look like this. So that's y cosine x from negative 360 to 360 degrees. If I wanted to draw cosec x, it'll look like this. I think we all know the answer to this one. It's quite easy. And then happy? Easier to understand it, right, than to memorize, I think. Last one, cot x. Anyone know how to draw cot x?
I've seen it.
Cubic.
Seen it?
Cubic. It's just cubic.
Just a cubic. Yeah, I guess so. Let's have a look.
Cubic limit, just do that.
Okay, you kind of memorized it. No, let's see. I don't know. We'll continue with our own strategy and we'll see. Because you got to assume if we've never seen it before, we're just going to follow it like this. Let's see if we can do it. Cot x. Move on. Everyone's okay with that? Cot x. Okay. So tan. Again, assuming you've memorized tan x. Memorize tan. Tan looks like this. Right, and then let's draw y equals cot x. Cot. Okay. Again, what's 1 over 0? Asymptote, undefined. What's 1 over 0 here as well? Also undefined. Okay, let's do it slowly. What's 1 over a small number? Big number, so we know we're going to start up here. What's 1 over a little bit bigger? A little bit smaller. A little bit bigger. A little bit smaller. A little bit bigger. A little bit smaller. What's 1 over infinity? 0. 1 over the world's largest number. Do it. If you had to get one pizza, go get one pizza. When you guys are done, cut into infinite slices. How much are you going to really get? You're going to almost get nothing. You're getting a crumb. You're lucky with a crumb. You're going to get almost 0. So right here. So 1 over infinity is going to get you right there, actually. Keep going. What's 1 over a very large negative number? It'll be a very small negative number. 1 over a little bit higher will be a little bit larger. And so 1 over very small, very large. And that's when they said it's going to be a cubic, but the other way around. Just as an extra piece of advice, 1 over undefined. So like this is an asymptote, right? Which you said is undefined. What's 1 over an undefined? How come? You remember it?
A big number.
No, because it's going to infinity. 1 over infinity is 0, so it intercepts.
Yeah. I know you guys know it that way. I'm asking, why does all of a sudden 1 over undefined become defined?
Because it's reciprocal.
Yes, you're very close. Tell me what specifically is reciprocating.
The asymptote.
So 1 over 0 from before, right? From before we said 1 over 0 equals undefined. Agreed? Now, yes. Now we're doing 1 over an undefined. 1 over an undefined. All right, well, undefined is 1 over 0. What's 1 over a fraction? Don't you flip the fraction? So 1 over any fraction is just a reciprocal. So then that becomes 0 over 1. What's 0 divided by 1? So if you did 1 divided by an undefined, it actually becomes 0. You should have said Eden's face. 1 over undefined is equal to 0 now. So it becomes defined, which is weird. Now, so technically it'll go through, but also technically it's an open circle. You can't all of a sudden make something that didn't work in the first place, do something to it and it works. So mathematically it's incorrect what I just showed you, but I can do a bit of algebra, like I've just done a bit of stuff, and I can make it look like it works, but mathematically it doesn't work, because in the first place it didn't work anyways. So the way it would look like, let's start again. 1 over small is large, so we know we're going to be up here. We're going to come down. As this gets larger and larger, this guy gets smaller and smaller. Same thing down here. 1 over small is large. It's going to keep coming up, and then the idea is it will look like that cubic you guys are saying. So it looks something like this. The problem is a lot of students just leave it at that. The reality is that's an open circle, because you can't actually tan 90 in the first place. So therefore you'll never be able to get to cot 90. Does that make sense? Because you can't tan 90, so therefore you can't cot 90 anyways. Does that make sense? So it'll go through it. Sorry, it'll go through it with your graph, like as you're drawing it. But technically, if I ever had to draw something like this, let's say in real life, it would actually look more like this. It would look like that. Then there'll be a gap, and then it'll start again. But you don't need to draw it like that. I'm just saying just draw it, and then just do an open circle so it doesn't go through. Yes. Make sense? Good. Now let's extrapolate it. Let's do it to multiple areas or multiple tans. So still copying that down. I'll go up. No. So y equals tan looks like this. That's one lot. And we're going to continue this. So if I continue, start from here, draw up, asymptote, start from the bottom, go ahead. So here we go. Draw up, asymptote, and there it is. That's at 2 pi now. And you can continue, but I'm not going to. There's this side, asymptote, and that would be negative pi. I'm not going to continue any more than that. Let's leave it at that now. Is that okay? That's y equals tan. Let's draw y equals cot. Okay, well, we know this is a asymptote. We know this is an asymptote. We know this is an asymptote. We know this is an asymptote. Oh God, there it is. Okay. And then pretty much we just do 1 over small, big, 1 over big, small. That's just the easiest way. So 1 over small is big, 1 over big is going to give me small. So I kind of know the answer is going to look like this. There it is. And then open circle. And you're just going to keep drawing that. Open circle. Open circle. What do we think? Is that okay? Yeah. Eden, what do you think? Seriously?
I was thinking there can never be like a negative amplitude for 10.
But there's no amplitude for 10.
Yeah, that's why.
Yeah. Because they go on forever. Mm-hmm. Okay. Let's actually look at a question involving maybe sec, cosec or something like that. So we'll do sec. So now that you kind of know the basics of it, you're going to apply it to the different cases of questions you might get. Okay. Sorry?
Do we have to dilate it?
Dilate it. Yeah, that's what we're going to do. Very fancy words. Y equals, now that you're in year 12, y equals 2 sec theta minus, no, not theta minus. Let's go to 2 sec 2 theta plus 3. And we're going to draw this from 0 theta to 360 degrees. All right, let's see how we would do this. So this is what I think this is as hard as it'll ever be. All right, it shouldn't get much harder than that one there. So if you can actually execute a sec 2 theta and the plus 3 and the times 2 at the front, you really get everything. Step 1, what's my amplitude? Step 2, what's my period? 2 pi on n, which equals to pi. So that means I should see sec every pi times. Yes? But how does 1 sec look like? So what you would do in your exam, real quick, just on the side here for yourself, is on the side, right? You just draw cos real quick. You're like, all right, I know that's 1 cos, so therefore 1 sec looks like this. 1 sec looks like that, that, and that. That's 1 sec. That's what you're meant to do. You're meant to quickly draw one little one for yourself because you need to know what one of them looks like. Because now every pi, we should see that shape in black. Instead of before, I had it from 2 pi. By the way, the domain here, you can either write 0 to 360 or obviously 0 to 2 pi. Because pi is 180 degrees. Okay. So now that we know what 1 sec looks like, let's see if we can draw it out. So take your time. Let's draw in a different color. Okay, slowly, very slowly. 2 sec 2 theta. All right, I just said that is 1 sec up here in black. And that's just a normal sec of theta. The 2 theta, now we understand, it just tell us that we're going to see it twice pretty much. But we're going to see one of these guys, instead of ending it at 2 pi, we're going to end it at pi. I'm just going to move my blue axis here to all the way here because I know I don't need any negatives. We're starting from 0. Okay, that's good. What else do I need to tell you? Oh yeah, what was this number here usually? 1. So now we know that that's going to be 2. Right? Because my amplitude is actually at 2 now. All right, so let's see if we would have drawn this. I'm trying to say, forget the rest now. Now that you kind of know what 1 looks like, don't overcomplicate it. Just draw it. Just draw 1. There it is. There's your asymptote. There's your parabola. There's your asymptote. There's your other part. But where does it stop? That's all. Pi. It doesn't stop at 2 pi now. Paddy, does that make sense? Because the period is pi now, yeah? So we're going to stop it at pi. And then you draw it again. Exactly the same thing. So you know what? Here it is. There it is. I'm sorry. Squishing it in. And I read out. But that becomes 2 pi. I couldn't do it. I ran out of gas. I'm sorry. Should have started more to the left. Now, that's okay. What number is this? And what number is this? Yeah, you're very right, but just wait. 2 and negative 2. Agreed? And now you've just drawn yourself y equals 2 sec 2 theta. That's all you've drawn. What we want to draw is y equals 2 sec 2 theta plus 3. So for you guys in year 11, when you see it, don't get too scared of it. You saw how simple I just approached it. I attacked it as if it was just a sec. The period told us every pi, so I just drew what I would normally draw, but then just stop it at pi instead of drawing it at 2 pi. The 2 just told us to start our amplitude at 2 and negative 2, something quite simple right now. Okay. Now, we want a plus 3, so we're going to move the whole graph up 3. Now, but yeah, instead of moving the graph up 3, something that you're taught in year 11, what you learn, or the way I teach it in year 12, is we don't really move the graph because it's going to be complicated moving the graph. Look at it. You want to move that graph, oh, it's annoying. So what I will tell you to do is actually just change this 2 to 2 plus 3, which is now 5. Instead of this being at 0, it's 0 plus 3, which means it's at 3. Instead of it being at minus 2, it's minus 2 plus 3, which is at 1. So where is my 0 axis? Just underneath. So my blue line is somewhere here. There it is. That's 0. And that's what we would have done. Does that make sense? It looks like the graph's been moved up, doesn't it? Especially if I get rid of this line. Look at that. Done? No, I can get done as well. That's right, you finished. I'll mark it, I'll give it to you on Monday.
Okay.
All right? I think Mum's probably outside. That's it, done.
Okay.
See you. Does it look like I've shifted the graph up? It does, without actually having to have shifted the graph up. So at school they'll tell you to shift it up and down, but it's smarter to move your axes up and down, left and right. That's a smarter way to do it. Okay, I'll bring it back. If you did have that in pen or for anything, you can just write don't mark. I don't know, whatever you want to write. If you want, you can highlight this and highlight this. Then we'll know that that's your axis. You can highlight the graph if you really wanted to, whatever, right? All good? That's really, really hard, especially for year 11. That's just beyond hard. But if you can kind of get that, then you'll really get those easy ones now. Shall we do one more? Yes, question.
So we all have to have the line.
Yeah, 100%. I had it in my exam, I just left it. You can write don't mark. I would have probably done something like this. But actually what I did is I drew my axes in pencil because I knew I had to move up and down. My axis was in pencil, my graph was in pen because I'm not going to be moving my graph. I'm only going to be moving my axes, right? So my axes were in pencil and then right at the end rubbed up the line on the top. And that's it. No one would have known what I've done. Only I would know what I've done. Okay, done.
You left it in pencil because big on the skin. You scan your exam from pencil to chalk.
Yeah, but back in my time there was no scanning papers, right? Now it's doing that because everyone remotely marks. Okay, one more. Let's go back to simple and like what you're probably going to get now. Y equals negative 2 sine 3x. Go. I'll give you guys a few minutes. I'll stop the recording.